An XDA class, also called Class G amplifier, twice 110 watts with remote control. An entirely digital DCC player recorder. A double-deck auto-reverse cassette player equipped with Dolby, B, C and HX Pro. A compact disc player with differential DAC 7-bit stream. A remote-controlled tuner with digital display. In just a few minutes, discover one of the most perfect hi-fi systems that exists, the 900 series system. With the 900 series, Philips have succeeded once again. Within a perfectly coherent system, the excellence of the separate elements is allied with the facility of use that all serious audio lovers expect. During replacement of the power transistors in the amplifiers FA920, 930 or 950, it's essential to readjust the quiescent current. For the amplifiers FA920 or FA930, the unit should be on standby position. Connect a digital voltmeter between points 1 and 2 for the adjustment of the left channel and set potentiometer 3285 to measure 12 millivolts DC. For the right channel, the voltmeter should be connected between points 3 and 4 and potentiometer 3284 set to measure the same value as before. For the amplifier FA950, a warming up time of about 10 minutes is necessary to obtain a stable situation for the adjustment. For the adjustment of the left channel, connect a digital voltmeter between points TP1 and TP3 and set potentiometer 323 to measure 15 millivolts DC. For the right channel, the measuring points are TP2 and TP4. Potentiometer 324 is set to measure the same value as before. Once the set of transistors in a power stage has been replaced and the associated elements checked, it's advisable to use a variac to supply the amplifier in order to avoid further destruction of the same components in case something is still wrong. Begin by connecting a voltmeter to the center point of the channel to be checked. Then adjust the variac to about 1/3 of the mains voltage. In this case, the mains voltage is 220 volts, so adjust the variac at 80 volts before switching on. Increase the power supply while checking that the voltage measured remains at 0 volt and that consumption remains weak. If the voltage measured varies abnormally, check the entire stage again. Open the drawer manually, unclip the ornamental plate and remove it. After having removed the power switch rod and different screws, remove the front panel. Remove the back of the cabinet and the printed circuit. Open the drawer manually. Then unlock it with the aid of a screwdriver. The drawer was disengaged by light pressure on this lock. Disconnect and loosen the power supply wires from the motor. Disengage the mechanism by pushing it towards the exterior. Remove the flex foil with the aid of a pair of pliers. Take out the CDM9. Once the CDM9 and the front panel are mounted again, the service position is obtained. The play mode functions in all positions. On its side, upside down, and of course the right way up. To gain access to the service mode, simultaneously press keys Play, Stop, Next, Previous, and switch on the player. The player displays versions of the microprocessors, User and Servo. The Stop key enables you to check that the display is working correctly. Pressing the forward search key moves the arm outwards. Pressing the backward search key moves it inwards. Pressing the Next key triggers Mode 1, Startup of Focusing. Insert a disc into the CD player. A second pressure on this same key will trigger Mode 2, Startup of the turntable motor. A third pressure will trigger Mode 3, Startup of the radial control system. A pressure on the Play key triggers the play function. In case of a fault, an error code will be displayed. As an example, error 04 indicates too many track loss pulses, meaning that track is not followed correctly. Desolder the SI-RD control line on pin 5 of the servo microprocessor 7701. The TDA-8808 is now functioning standalone. The laser should be switched on. The voltage on line LO of pin 17 is about 3.2 volts. The voltage on line LM on pin 18 is about 0.2 volt. To check the photodiodes of the CDM9 mechanism, send an infrared signal into the lens of the optical pickup with the aid of a remote control unit. The code transmitted should be visible on the oscilloscope at the 4 inputs, 22, 23, 24 and 25 of the TDA-8808. On the outputs RE1 pin 21, RE2 pin 20 and FE pin 15, the code is also available. The lens reacts on the error signals on pin 22 up till 25. If pin 22 or 24 is forced to earth, the lens is going down. If pin 23 or 25 is forced to earth, the lens is going up. The generation of the HF signal may be checked by turning a disc manually. The HF out signal on pin 3 of the integrated circuit should have an amplitude of about 1.5 volts. Remove power switch rod. Lift up the decoder printed board panel. Open the tray manually. With the aid of a screwdriver, unclip and remove the ornamental plate of the tray. Push tray inside, remove the front panel connectors, and remove the front panel. Place the tray in the medium position. Disconnect the flex foil connector. Lift the arm of piece 96, then remove the carousel. Unclip the lug, then remove piece 90. Loosen the screw situated in the center of the carousel. Remove plate 89 by turning it upwards. Remove the rotary support numbered 100 and the lug 101. After the wiring has been loosened, demount the servo-printed board. Disengage the two clips from beneath in order to free the CDM locking bracket 99, then remove this bracket. The CDM 12 mechanism must be disengaged from the transparent suspensions. The user data stored in the memory of this unit is erased when entering the service mode. It's therefore necessary to note this data before the service mode is started. Entering the service mode by pressing simultaneously mono and search down and then power on. When returning to normal use, all stored data has now been erased. To follow these measurements, look at the adjustment table in your service manual. Connect a voltmeter to the collector of transistor 7109. On the FM wavelength, tune to 108 MHz and check that the voltage is between 7 and 9 volts. For this set, the reading is 7.8 volts, so within the requirement, as you can see. Then tune to 87.5 MHz and check that the voltage is now between 1.3 and 2 volts. On long wave, tune to 279 kHz and adjust coil 5108 to measure 8.5 volts plus or minus 0.1 volt. Then tune to 153 kHz and verify that the voltage is now at 1.2 volts, plus or minus 0.1 volt. On medium wave, tune to 1611 kHz and adjust 2142 to measure 8.5 volts, plus or minus 0.1 volt at 0.7. Then tune to 822 kHz and check that the voltage is 1.4 volts, plus or minus 0.1 volt. Into the aerial input, inject a signal of 98 MHz and 1 millivolt amplitude. Tune the tuner to this frequency. Then adjust coil 5105 in order to obtain a voltage of 0 volts, plus or minus 20 millivolts, between points 1 and 2. Into the aerial input, inject a signal of 98 MHz and 15 microvolts amplitude. Tune the tuner to this frequency. Connect the oscilloscope to test point 5 on pin 9 of connector 1112. Then adjust potentiometer 3125 to the switching threshold 5 volts, 0 volts. As indicated in this diagram, solder a coupling capacitor of 100 nanofarads onto pin 27 of integrated circuit 7103, then a resistance of 50 ohms between the earth and the condenser. Via this circuit, inject a signal of 1494 kHz and 1 millivolt amplitude with an amplitude modulated signal of 1 kHz. The modulation must be set to maximum. Tune the set to 1494 kHz. Measure the signal at test point 7 on pin 5 of IC 7103. Adjust coil 5104 in order to obtain a signal of maximum amplitude and maximum symmetry. Connect the AM aerial to the tuner. Then position a second AM aerial, used for transmission, at about 20 centimeters in front of the first. For medium wave, into the transmitting aerial, inject an AM signal of 558 kHz and 5 millivolts amplitude. The modulated signal is 1 kHz. The degree of modulation is 30%. Tune the tuner to 558 kHz. And adjust coil 5107 in order to obtain maximum amplitude of the signal at measuring point 7. Change the frequency of the generator signal to 1494 kHz and tune the tuner to this new frequency. Then adjust condenser 2141 to obtain maximum amplitude of the signal at point 7 once more. As these two adjustments are interactive, it's advised to repeat them several times in order to obtain an optimal result. For long waves, into the transmitting aerial, inject an AM signal of 156 kHz and 5 millivolts amplitude. The modulated signal is 1 kHz. The degree of modulation is 30%. Tune the tuner to 156 kHz. And adjust coil 5109 to obtain maximum amplitude of the signal at point 7. Change the frequency of the generator signal to 270 kHz and tune the tuner to this frequency. Then adjust condenser 2140 to obtain maximum amplitude of the signal at point 7. As these two adjustments are interactive, it's advised to repeat them in order to obtain an optimal result. Turn the playback head in order to place the two markers in this position. Lift the head. You should hear a click. Then push the head towards the interior in order to disengage it. Separate the head from its support. When mounting, pre-position the head in its housing. Turn the white piece in order to bring the two markers in line with those of the head. Lock the assembly. With the aid of a screwdriver, move the fixation system to one side and at the same time lift plate number 51. Unclip the rear part of the piece, which is secured by two lugs. Remove plate 51. Loosen the two screws which secure the motor, then repeat the same operation in order to take off the second plate, numbered 61. You may now remove the drive belt. For reassembly, begin by placing the drive belt like this. Clip in plates 61 and 51. Secure the motor, then with a pair of tweezers, settle the drive belt into the groove of the drive pulley mounted on the motor axis. To follow these measurements, look at the adjustment table in your service manual. Connect an oscilloscope to the right and left outputs of the unit. Play back the 8 kHz signal which is recorded on side 1 of test cassette SBC420, played back in normal direction. Once the cassette door has been removed, adjust the left-hand screw in order to obtain maximum amplitude and minimum phase shift between the two channels. Repeat the same operation for the reverse direction. Then adjust with the right-hand screw. Read the cassette torque meter, reference 811 CTM. Adjust potentiometer 1635 to measure a tape tension between 45 and 50 grams per centimeter. Repeat the same operation for deck B, but adjust 1636. Connect a frequency counter to either the right or left audio outputs of the unit. Activate the service mode by simultaneously pressing the keys stop and forward and then switching on the player. Play back the 3150 Hz signal of cassette SBC420 by pressing the play key. Adjust potentiometer 3704 to read a frequency of 6300 Hz, plus or minus 200 Hz. Connect a frequency counter to one of the two audio outputs. Read the 3150 Hz signal of cassette SBC420. Adjust potentiometer 3705 to measure a frequency of 3150 Hz, plus or minus 100 Hz. Insert test cassette SBC420 and play back the 3150 Hz signal. Adjust for the right-hand channel potentiometer 1632 to measure an AC voltage of approximately 550 millivolts between test point Dolby Ref R and earth. Adjust for the left-hand channel potentiometer 1631 to measure an AC voltage of approximately 550 millivolts between test point Dolby Ref L and earth. With the aid of a generator, inject a signal of 315 Hz and 75 millivolts to the left input line in. Short circuit points 8 and 9 of 1659. Adjust potentiometer 1633 to measure on AC voltage 25 millivolts between point 3 of the connector 1605 and earth while recording a chrome cassette. Verify that the voltage at point 3 of connector 1605 is at 20.5 millivolts when recording a ferro cassette. Please do not forget to disconnect the short circuit. Turn potentiometer 1626 to its maximum in an anti-clockwise direction. Adjust coil 5627 to measure a maximum voltage between point 3 of connector 1650 and earth while recording a chrome cassette. Adjust potentiometer 1626 to measure on AC voltage 270 millivolts at the same point. Insert test cassette SBC419 into the player and check the measurement on the line-out connection. Check that the Dolby switch is at the off position. Then play back the 40 Hz signal and note the output level. Play back the 250 Hz signal and note the output level. The 6.3 kHz signal. The 12.5 kHz signal. The 14 kHz signal. Then trace the frequency response curve and check that it compares correctly with the inspection scale. The reference 0 dB corresponds to the value of the signal at 6.3 kHz. Insert a Chrome cassette and set the unit in recording mode. Inject a signal of 315 Hz at the point Dolby Ref L C2436 and adjust the generator to measure an AC voltage of approximately 3.3 mV between 0.5 of connector 1660 and earth. Once its amplitude has been set, the signal is now injected at 0.4 of connector 1660. Leave the cassette deck running and for a few moments record a series of signals. 63 Hz, 250 Hz, 2 kHz, 10 kHz, and finally 12.5 kHz. To check the frequency response, you only need to play back the cassette and note for each frequency the AC levels at 0.5 of connector 1660. Trace the frequency response curve and check that it compares correctly with the inspection scale. The reference 0 dB corresponds to the value of the signal at 2 kHz. If the level of the bias current is too low, the curve deviates from the inspection scale in an upward direction. If the level of the bias current is too high, the curve deviates from the inspection scale in a downward direction. Readjust if necessary. Inject a signal of 315 Hz and 75 mV effective at 0.4 of the connector 1660. Insert a ferro cassette and record this signal for a few moments. When the cassette is played back, the AC voltage at the point Dolby Ref L should be 550 mV, plus or minus 60 mV, equivalent to plus or minus 1 dB. Connect the right and left outputs to a dual-beam oscilloscope. Play back the 8 kHz signal of test cassette SBC 420. Turn the right-hand adjustment screw in order to obtain minimum phase shift and maximum amplitude. Note the position of the screw. Then continue to turn it in the same direction until a phase error appears. Note this new position and adjust the position of the screw between these two markers. Perform the same operation with the left-hand screw for side B. Measure the frequency of the signal at the right or left line output while playing back the 3150 Hz signal. First, it's necessary to adjust side A. To do this, adjust RSO2 to obtain a frequency of 3150 Hz, plus or minus 5 Hz. Then adjust tape speed for side B with RSO8. Use the digital board extension card. Connect a frequency counter to measuring point J442. Adjust R455 in order to obtain 7.5 MHz plus or minus 0.1 MHz. Check that the Dolby is switched off. Note the amplitude of the line out signal while playing back the 4 kHz signal of test cassette SBC 420. Adjust R645 in order to obtain approximately the same amplitude while playing back the 125 Hz signal. Adjust R643 in order to obtain approximately the same amplitude while playing back the 14 kHz signal. Adjust R633 to obtain an AC voltage of about 390 mV at point 3 of J601 while playing back the 315 Hz signal. Adjust RL05 for the left channel and RL06 for the right channel in order to position the level indicator at 0 decibels while playing back the 315 Hz signal. Insert a pre-recorded DCC cassette. Then, to assess the service mode, press the keys Stop and Play simultaneously while switching on the player. Service mode is displayed, and a list of the available characters is displayed in sequence. To change the sequence, press the Time key. Sequence 1. All the display elements and the LEDs light up. Sequence 2. The LEDs and then the display elements switch off one by one. Sequence 3. This sequence cannot be used during maintenance operation. Sequence 4. After pressing the play key, a percentage of error is displayed. If the reading of the system information is correct, the percentage is 000. Sequence 5. A percentage of errors is displayed. If the reading of the auxiliary information is correct, the percentage is 000. Sequence 6. This sequence enables the channel-by-channel check by the percentage of errors. Choose the channel you wish to check by using the remote control unit. For example, channel 0, no errors. Channel 3, no errors. Channel 5, X% of error. Here the head is defective. Sequence 7. The averages of all errors per channel are displayed. In this example, the reading is correct. In this one, the cassette is defective. Sequence 8. The instantaneous errors per channel are displayed. In this example, the reading is correct. In this one, the head is defective. Open the tray manually by using the drive pulley. With the aid of a screwdriver, unclip and remove the tray ornamental plate upwards. Unscrew and remove plate 060G. Disconnect J701, then other connectors. Loosen the front panel, place it face down in front of the player. Unscrew and move the mechanism towards the left. All measuring points are now accessible on the component side of the main board, on the digital board with the aid of service extension card, on the ADDA board with the aid of service extension card, on the component side and on the soldered side. A service cover is provided to allow access to the measuring point soldering side of the main board. The measuring points on the front panel are also easily accessible. Place the tray in the middle position. Then remove spring 41N. Unclip and remove the cassette clamping bracket. Remove the entire tray, paying attention to the metal bearing ball. Disconnect the flexible foil from the reed right head, then the 4 other connectors. Unscrew and remove the DCC mechanism. The complete DCC mechanism is available with a service code number. Move the clamp to one side and remove the pressure roller assembly. Unlock J101 and remove the flexible foil. Unscrew and remove the reed right board. Remove these 4 screws and then the plate. Remove the flywheels with capstan. The drive belt is now free. Mount the 2 flywheels. Position the drive band like this. Mount the plate. With the aid of a hook, pull the drive band onto the motor drive pulley. Fix the plate. Slide the pressure rollers into their housing. Connect and fix the reed right board.